Hi, welcome to a video on graphing basic exponential functions. Today we're going to graph two exponential functions, one with a base greater than 1 and one with a base less than 1. But first, here's a quick review of some of the properties of exponential functions. They always have the form f of x equals a b to the x. B is called the base. That's going to be important as to whether it is a growth or a decay function. And if the base is greater than 1, we know that it's growth, and if the base is less than 1 but positive still, it's going to be a decay function. Okay, so on to our two examples. So we're going to take a look at graphing the function 3 to the x plus 1 power. So this is just a transformation of the function f of x equals 3 to the x power. So all the extra x plus 1 does is it takes this basic function, and this guy here is just a shift of that function to the left 1 unit. So if you know what the basic exponential function looks like, which is a j, follows along the x-axis just above, not touching, always has the same y-intercept of 0, 1, then you can just take that function and shift it to the left 1 unit. So starting with just sketching this f of x equals 3 to the x, this is a function with the y-intercept of 0, 1. It has that j sort of look to it, shall we say, and it comes along just like this. So identifying just a couple key points here, this guy would have the y-intercept right here at 0, 1, and just one additional point would be that it would also have the ordered pair 1, 3. So this would be the function y equals 3 to the x. Okay, so the function we want to graph, y equals 3 to the x plus 1, if we just take this green function and shift it to the left 1 unit, that's going to be the function that we want. So if we take the point 0, 1 and shift it to the left 1 unit, and then take our point 1, 3 and shift it left 1 unit, and then connect our dots using that same sort of form, then we've got a sketch of our y equals 3 to the x plus 1. Now, of course, you can always plot, more ordered pairs if you need to. So if you want to just get a few ordered pairs and put them into the function, then that's easy enough. Easy point to pick would be 0 for x, because 3 to the 0 plus 1 is the same as 3 to the first, which is 3. So 0, 3, and you can see that's a point on our graph. Another good point to pick is -1, because when you put -1 into this function, you get an exponent, -1 plus 1, of 0, and 3 to the 0 is just 1. So -1, 1, and that's the other point on our graph. Again, you could plot more points, but if you know the general shape of the picture, then that's all you really need to do. Okay, let's take a look at a different one. Let's take a look at the function 1/2 to the x minus 3. Now, as mentioned earlier, if your base is less than 1 but greater than 0, then you're going to have a decreasing function. So we're going to have a function that from left to right goes down. It's going to be shifted because of this x minus 3. Because of the minus 3, it's actually going to be a shift to the right of 3 units. So while, the regular exponential function, the one that this sort of comes from, of y equals 1/2 to the x, well, this function would have the y-intercept at 0, 1 and be a decreasing function. Yours is just going to shift the other direction. So let me put in sort of what the y equals 1/2 to the x looks like. So decreasing like this. Oops, sorry about that. So from left to right it's going down. Alright, so yours is going to be that function but shifted to the right. So if I take my y-intercept of 0, 1 and shift it to the right 3, 1, 2, 3, that puts me over here at the ordered pair 3, 1. And then if you just shift every other point on that green graph, to the right 3 units, then you've got your new graph. So your graph is going to be something similar to following along here and then shooting upwards. So let's see here. It's going to be very steep. So that might not be perfect, but if we want to get a little better, of course, we could always plot a few ordered pairs here. So if you want to pick some x values and plug them into the function, then we could do that. An easy point to pick is 3, because when we plug 3 into our function here, we end up with 3 minus 3, so we end up with a half to the 0 power, which is 1. So 3, 1 is our point there. Another point that might be nice to pick, we could pick 4 or go the other direction. So let's say we pick 4. Then we have 1/2 to the 4 minus 3. So that would be 1/2 to the first power, which is a half. So that would be another ordered pair, 4, 1/2. But how about we plug in, say, 0? Let's get the y-intercept. So if you plug 0 in here, you're going to have 1/2 to the negative 3 power. And the negative 3 power is the same as flipping this over, 2 over 1 to the positive 3 power. And 2 to the third is 8. So actually I can adjust my graph, make it a little bit better, because I see that it has actually the y-intercept of 0, 8. So it should be going through this point over here. So let me make a little adjustment on my picture here. Let's have it going through 3, 1 and up through that y-intercept right there. Oops, let's close that up at 0, 8. Great, I hope this has been helpful.